Okay, welcome America, welcome India, and welcome Taylor Swift. My voice is probably still a little different. Is my voice different still? No? Good. Okay, awesome. I'm getting better. So we're going to do some of these review problems for our first test in Unit 6. And I thought I would start with some of the problems that I haven't done yet, because I do already have 3 videos, part 1, part 2, and part 3 of this exact same worksheet. So I'm going to pick a couple different problems. And we're going to start with number 1. Is everybody ready? All the phones should be away. Okay. When you are asked to simplify a ratio, and we've got different units, we have to make the units the same first. This is the most common mistake when you're taking this quiz or test, is not making the units the same. So how many ounces are in a pound? Anyone remember from I don't know. Okay, do you know that from science, or is it from Gourmet Foods, or you just happen to know it? Okay, so 16 ounces in a pound. So how many ounces? We're gonna take the larger unit, which is pounds, and we're gonna chop it up into the smaller unit, which is ounces. So we're gonna leave the 34 ounces, and we're gonna change 4 pounds to ounces. So 4 pounds times 16, how many is that?
64.
Okay, so that's equal to 64 ounces. Is everybody good with that? Now that the units are the same, they're going to cancel, and then we can simplify. So you go to your Desmos calculator. Shoot, I can't do that up here because I've got the annotation. Go to your Desmos calculator. Type in this fraction, 34 divided by 64. And then push that button that looks like this. On the left, the blue button. And it will simplify the fraction for you. And what do you get? What is it? 17 over 32. So that means that only 2 goes into 34 and 64. The greatest common factor of 34 and 64 is 2, right? So what was that again? Let me write it here. Oh, shoot. 17 over 32, right? That's it. There you go. You have simplified the ratio. Don't forget to make the units the same first. Once the units are the same, then you can simplify the ratio using the calculator. Any questions? I have myself doing a couple of these problems in the test review on the other videos, and you can watch them if you want some more practice on that. Solving a proportion. I'm going to go and do in the last review video that I did number 7. If you want to watch me do number 7, you can watch that video. I'm going to do number 8 because I haven't done this one in a video yet. So we cross multiply. When you cross multiply, you need to remember there's a parentheses. It's not a big deal to not remember the parentheses around the 2 and the 8 and the 20. Okay, but this is a 3x minus 10, which means 8 times the quantity 3x minus 10 equals 2 times 20. I'm just going to write 40. Now we have a choice. We can either distribute that 8 to the 3x and the 10, or we can divide both sides by the 8. Since 8 goes into 40 evenly, right? 5 times 8 is 40. We know multiplication facts, and we're going to have one of those times tests coming up pretty soon, 4th grade. I'm going to choose, rather than distribute, if someone would like to distribute, that'd be awesome, because then we can check our answers and see if they're the same. If someone wants to distribute the 8 to the 3x and to the minus 10, I'm gonna choose to divide by 8. It's just less work. This becomes 3x minus 10 equals 5 plus 10 plus 10. Somebody's checking my work, because I do make mistakes. I have 3x going into 15, so I'm getting x is 5. Did anyone else get x is 5? You did? You did? Did anyone distribute the 8 to the 3x and to the 10 and get like 24x minus 80 and then do the problem that way? Did you also get the same answer?
Yeah.
Okay, so we've got people that did the problem a totally different way and got the same answer, and that's perfectly fine. And that's just how math is. You know, as long as you do legal moves in math, and you have options. You got all these tools in your math tools in your bank, and you're just picking whichever one you see that seems to be the most efficient for you. So great. Any questions on how to simplify a ratio or solve a proportion? Okay, erase. Geometric mean. I believe that I did the geometric mean number 9 already, so I'm going to go and do number 10. 3 and 16. The square root of 3 times 16. Now, I could multiply 3 times 16. Perfectly fine if you did that already. However, I know that 16 is a perfect square. So I'm just going to take that out. What's the square root of 16?
4.
Done. There's your answer. Any questions on how to simplify that? We could talk about that. We could talk about some more radical problems. Is everybody good with that? I mean, we're not in a rush. We got do some more like that. Are we good? Everybody's okay with that? Okay. All right, so these 3 problems are very important. And make sure you watch the video that's called Perimeter Area and Extended Ratio to do these 3 problems. They're very important and they're not hard, but they're totally new. And anytime something is totally new, it's not easy. It takes practice. Practice? We're talking about practice? We're talking about practice. When you see me go into the arena, you see me play, don't you? Give it all I got. We're talking about practice, man. What are we talking about? Practice? How am I gonna make my teammates better? Practice. Gosh, I love that video. Okay. When you get polygons, I'm moving on to 13 and 14. When you get polygons and it's asking you to determine if they're similar, you need to check all the angles to corresponding angles to make sure they're congruent, and they are. But then you need to check the sides and make sure the ratios are the same. So 6 is to 15, 6 is to 15. That ratio should be the same as 10 to 25. So you just take out your calculator and you check them. And you simplify those ratios. Are they the same? When you simplify. 3 goes into 6 2 times. 3 goes into 15 5 times, right? 5 goes into 10 2 times. 5 goes into 25 5 times. I'm getting 2 to 5 for both of those, which makes these figures similar because the ratio of the sides, all the sides are the same. You got to be careful with this one because it's been flipped. You see how this angle corresponds to this angle over here, and then this angle corresponds to this angle over here. I would, if you get confused with that, and a lot of people do, redraw the second one and flip it and put all the numbers. Then it's easier to see which sides correspond to which sides, so you can do this and make sure the ratios are all the same. Is everybody okay with that explanation? Yeah. I feel like we're doing really well so far. I feel like you guys are like with me. All right, so I want to kind of talk about a scale model. Anytime you get a scale model problem, it looks really complicated. However, when they give you the scale, for every 1 there's 15. That's half of your proportion right there. It's so wordy, right? You can buy a scale 1. The length and the width of the actual Firebird is 1. Okay, so there's for every 1 in the model, there's 15 in the real car. So I'm going to write model here, just to remind myself that's the numerator is model, and then actuals down here. Now, since I put the model in the numerator and the actual in the denominator on the left, then I just have to do the same on the right. I have to put the model information up here and the actual down here, just because that's what I chose. Now, if the length and width of the actual Transit is length and what are the length and the width of a model car? So those are two separate problems. Is it hot in here? It always gets hot in here. Okay, so we'll start with the length. Okay, they tell you that the length of the actual one. We'll start with this 189.8. Where is that going to go over here? Is it going to go in the numerator or the denominator? That number. Because we have to put the model number over the actual, and they're giving us what? What are they giving us? Actual. So that number has to go down here. You got to put it in the right place. And then they're asking us what's the dimension of the model, so that's your x. Well, now you have three numbers and then one x, and now it's just like those proportions that we were solving. Now it's the same. And the one thing you don't need to worry about, okay, are the units here. Because this is a proportion, it's not a ratio. With the ratio, you've got to make the units the same to simplify. When you have a proportion, you don't have to worry about that, okay? Because it's consistent on both sides. You can cross multiply and divide. So this is 15 times x equals 189.8 times 1, so that's 189.8. Can someone do this on the calculator? Man, is it hot in here. And what are you getting? I don't know the answer. 12.7. Did anyone else get 12.7? Confirmed, 12.7. And then let's see, what are the units? Actual car. I'm looking. Where are the units for the actual car? They're not inches. Is it inches? You can buy a scale on the length of the inches it is. Really? That's not right. It's gotta be feet or something. Let's look at my answers. Does it say here? It usually says, I'm surprised. Does somebody else see it? The units for the actual car? On a quiz or a test, the units will be there. Okay, so sorry, I should have figured this out before I started recording, but it's fine. What number was that? 12? Length with the actual. Okay, they didn't give it to us, so it's just weird that the actual car is 12. Those units are like the actual car can't be 12.65 inches. It's got to be like feet or something. Whatever. On your actual test, that will happen. And the last type of problem. Oh, this is already 13 minutes. I'm gonna go.